My dear student, welcome to School of Fundamental Sciences, SOFS. I deliver some fundamental concepts of physics, chemistry and mathematics for JEE Main and JEE Advanced. It will give me great pleasure if you enjoy this concept. My dear student, let us start. Applied differential calculus, second part, discussing finding maximum and minimum for a function. Let y is equal to fx. And this is the graph of the function y equals to fx. Clearly you see at x equals to x1 it is the maximum value of fx, and at x equals to x2 this is the minimum value of fx. What is the result? To find this maximum value we must have dy dx equals to 0, because if you draw a tangent here, tangent makes an angle 0 with the x-axis. So dy dx equals to tan 0 is equal to 0. And second derivative, it requires some more concepts. Later on we will discuss. It will be d2y dx2 must be less than 0 for maximum value of the function. For minimum value of the function also dy dx 0, because you see tangent is parallel to x-axis. So theta is 0, so dy dx is 0. And if we find the second derivative d2y dx2, it will be greater than 0. Now actually in applied sciences, mainly physics and chemistry, the maximum value or minimum value for a given problem we know. So to find the maximum value or minimum value, second derivative is not required. So usually we can omit second derivative for maximum and minimum value. Now see sample problem 15. The position x of a particle moving along the x-axis as a function of time is 3x equals to t cube minus 3t square plus 21t, where x is in meter, t is in second. Now we have to find the minimum speed of the particle. So let us see. X equals to this, it is given. So what is the velocity or speed? Dx dt is equal to ddt of x. X means 1 by 3 t cube minus t square plus 7t. Now applied property of differential coefficient. So 1 by 3 ddt of t cube minus ddt of t square plus ddt of 7t. 7 is taken out, property. So it gives the word 3t square. So 3 cancel out, t square minus 2t plus 7, because ddt equals to 1, you know. So what is dv dt? Now next we will find dv dt. It is a ddt of v. So what is v? T square minus 2t plus 7, that we have said here. So it will be 2t minus 2, and find the second derivative, d2v dt2 equals to what? ddt of dv dt, meaning of d2v dt2. You see, verify, dd means d2 and dt means dt2 equals to ddt of what is dv dt? 2t plus 2t minus 2, 2t minus 2 equals to 2 greater than 0. So obviously v must be minimum if dv dt is equal to 0. You see our result. This implies dv dt is equal to 2t minus 2. So 2t minus 2 is equal to 0. So t equals to 1 second. Therefore v is equal to t square minus 2t plus 7. Yes, that we have obtained here. V is equal to this one. That is V is equal to, we can have complete dimension. So 1 must have the dimension. T square means, or 1 t square, 1 must have dimension meter per second cube, because if you put t in second, you see it will be meter per second. Verify. Similarly here 2 must have dimension 2 meter per second square, because if you put t is equal to second, it will be meter per second equals to dimension of V. 7 also dimension 7 meter per second. So what is the minimum value? V will be minimum already established when t is equal to 1 second. So put t is equal to 1 second and calculate, it will be 6 meter per second. Now message. Here we have obtained minimum value by using calculus, that is dv dt is equal to 0 and d2v dt2 greater than 0. Without calculus also we can find this problem. We can find minimum value of this problem algebraically also. Let us see how. V is equal to t square minus 2t plus 7. It is a quadratic in t, so t square and 2t just you convert into perfect square. So it will be t minus 2 whole square plus 6. You see, t square minus 2t plus 1 and plus is equal to plus 7. Now what is the V minimum? When t minus 2 whole square minimum plus 6. So V minimum equals what? Minimum value of t minus 2 square plus 6. Now t minus 2 is a real number. A real number square means always greater than equals to 0. So what is the minimum value of a real number square? 0, 0, 0. That's why minimum value 0 plus 6 equals to 6 meter per second. when it becomes maximum, when t1 minus t2 whole square is equal to 0, minimum value, so t is equal to 1 second. So for t is equal to 1 second, we have obtained v minimum is equal to 6 meter per second. Already I have given the fact also, t minus 1 whole square being a real number greater than or equals to 0 for all real values of t, and that's why minimum value of t minus 1 whole square equal to 0. And again you see, let us see what will happen. Can you find the maximum value of v for this expression or not? The v is equal to t minus 2 whole square plus 6. It tells us that v tends to infinity when t tends to infinity. That is, maximum value does not exist, because when the value of any parameter like velocity here tends to infinity, so it here tends to infinity means plus infinity, as large as you can imagine it has no finite value, so it cannot be the maximum value, so its maximum value does not exist. We can also have a graphical concept also. Graphical concept, you see, to get some more idea of graph you can have the clear understanding. Till now let us explain this. You see, before drawing the graph, you notice the following facts. Now you see dvdt is equal to, when dvdt less than 0, that is dvdt is equal to what? 2t, dvdt 2t minus 2. So 2t minus 2 less than 0, that is t less than 1 second. Then the particle undergoes deceleration. Why? The dvdt negative means what? V decreases. When t increases, v decreases. So v decreases means there is a deceleration. That is, v decreases with the increase of t less than 1 second. See here, when t increases up to 1 second, less than 1 second, v decreases. Again, next you see, when dvdt greater than 0, that is t greater than 1 second, the particle undergoes acceleration, because dvdt greater than 0 means what? V increases with the increase of t. So when t increases, v also increases. And since it is a continuous function, so clearly at t is equal to 1 second, we have the what? Minimum value of v. And clearly at t is equal to 1 second, minimum value of v is equal to 6. So graphically also we can have the answer. It is a graph of v is equal to t minus 1 whole square plus 6. Actually it is a parabola. Now you see SP16. The particle starts moving along the straight line with decreasing acceleration. Acceleration is decreasing. So be careful. The velocity of the particle is increasing, but increasing at the decreasing rate. Decreasing acceleration means what? Velocity increases. But decreasing acceleration means what? Rate of increase of velocity gradually goes on decreases. In mechanics, it is actually concept of terminal velocity. So here also you see the decreasing acceleration means velocity increases, but velocity increases at the slower rate. The rate of increase gradually goes on decreasing. That's why decreasing acceleration. Now question is, the velocity of the particle as a function of t is given here. So we have to find the maximum speed of the particle. So please you see, since the acceleration is decreasing, so time will come when the acceleration becoming 0, and obviously at that point the velocity becomes maximum, because acceleration means velocity increases, but since acceleration decreases, so gradually the acceleration dies down to 0. Once the acceleration dies down to 0, velocity becomes maximum there. That property I have used here. You see, v is equal to this given in the problem. Let us find dvdt by using this property. 10 meter per second square, ddt of t minus t square by 22 second equals to 1 minus 2t by 22 second. Ddt of t is equal to 1 minus ddt of t square by 22 second means what? 2t by 22 second. Now v becomes, already explained, maximum when dvdt is equal to 0, that is when acceleration becomes 0. So dvdt 0 means what? This equals to 0. So 1 minus 2t by 22 second equals to 0. So t is equal to 11 second. So now we can find the maximum velocity from the expression for v. So v equals to 10 meter per second square, t minus t square by 22 second yields v maximum when t is equal to 11 second. Already you have calculated. So v max equals to 10 meter per second square, put t is equal to 11 second minus 11 second whole square by 2 into 11 second. So equals to this into 11 second minus 5.5 second equals to 55 second meter per second. So this is the required velocity of the particle. Now you see message, no need to check the second derivative because already we know, already explained also, the when dv is equal to 0, the velocity is maximum. That we know, already explained. But if you verify second derivative, then also you say the second derivative must be less than 0. You can verify. dv d2v dt equals to what? ddt of dv dt is a dd d2v dt means dt2 equals to ddt of dv dt. Put the value, put the expression for dv dt that we have done. 10 meter per second square 1 minus 2t by 22 second equals to 10 meter per second square taken out. So ddt of this one is equal to 10 meter per second square. ddt of 1 is 0 minus 2 ddt of t1 2 by this second. Clearly you see less than 0. So obviously this implies v becomes maximum.